Welcome to the lecture series. In this lecture series, we are discussing about the supervised and unsupervised learnings. And here we are going to discuss about the another important and interesting topic like object detection and image-based localizations. And in the machine learning and in this evolutionary concepts or computation techniques, we are usually focusing on this concept like localization, path planning, and perspective, etc. So here we will discuss how this localization, path planning, and perspectives are used in this object detection and image-based robot. First is object detection is identifying and locating multiple objects within the images or the videos, or we have to give a pattern and to find out from it. And next is image based localization is we are determining the camera position from the visual data. And integration is nothing but combine the systems enable the advanced perceptions in the robotics. And the growth here found is a rapid advancement driven by deep learning and the increased computational power. And first of all, we have to understand what is the user need. So how many people interact with the visual data? And from that research methods, the interviewers observation and contextual inquiry, we have to finalize it. And in the robotic this object used in the navigations, object manipulation, human robot interactions. And the visual challenges we find here is lighting, collisions, and viewpoint variations. So defining is object recognition, we use image classification and object localization, and these both are used for the object detection and used in the image segmentation. And here the problem statement is how we can create a robust system that accurately detect the object and determine the spatial position. So here the key parameters we have to focus on is perspection, precision, speed, adaptability, and resource efficiencies. And critical challenges we focus is illusion, light variations, computation constraints. And success parameters also we focus on accuracy, processing time, and robustness across the environments. And for fundamentals like classification, so identifying the object categories within this image, and we classify and separate these two images. Localization is determining precise object positions with the bounding boxes. And key components we focus on here is feature extraction, region proposal, classification, refinement, etc. And performance matrices here is position, recall, FN score, and interface time. And here the algorithms we have is two stage detectors. One is a region based convolution neural network, and fast region based convolution neural network, which gives the improved efficiencies. And we have faster region control convolution neural networks, which is useful for the region proportional networks. And single stage detectors are also available, that is YOLO, that is you only look once, like the editable non-editable document. SSD, that is single shot multi-box detector. And retina net, which focuses on the focal loss. And performance comparison is two stage is greater than the single stage in the terms of accuracy. And in the terms of speed, single stage is more speed than the two stage. And in trade-off, we go for the MAF versus the FPS. And image based localization techniques, we have structure based methods, that is 3D reconstruction, feature matching, and PNP algorithm. In the 3D reconstructions, we have the uh, SFM, SLAM, etc. And coming to the image retrieval based method, we have a database matching, descriptor indexing, and post interpolation. And learning based methods also, we have few methods like absolute post regression and scene coordinate regressions, hybrid approaches, etc. And these are used for certain applications like end-to-end learning, mapless approaches, and combining methods. Coming to the applications, we have implemented in robotics, autonomous vehicles, augmented reality, and industrial automations. And coming to the object manipulation, in robot, you can find it object manipulation, navigation, path planning, and robot interaction. In autonomous vehicles, is obstacle detection, lane recognition, precise positioning, and so far we use in augmented reality like visual object placement, environmental mapping, and real-time tracking. And yes, industries we used it for the quality inspection, inventory management, and automated shortings. And finally, coming to the development stage, we look for the creative techniques and innovative approaches. And prototype development, we go for the model selection, data preparation, implementation, and optimization. Once after the optimization, we look for the performance matrix, we validate it, and we go for the challenge scenarios like edge cases, and we iterate, like we refine